Hi, I am Binsi and my channel is Binsi's Class. I am an ICSE Class 10 Physics teacher since last 14 years. Here I solve 10 years previous question papers. If you watch and learn from my class and follow my instructions, I assure you that you can score above 95% in physics. So please watch, like, comment, share and subscribe my channel. Kindly click the bell button to get all notifications. Our second unit is light. In that we are learning about refraction of light mainly, then total internal reflection, spectrum, all those things, isn't it? From that chapter, every year we can expect 20 to 25 mark questions. Even last year 2020 also we got nearly 20 mark questions. Okay, that is the reason we are starting with this unit. Okay, that first question is, a ray of light falls normally on a rectangular glass slab. Draw a ray diagram showing the path of the ray till it emerges out of the slab. Okay, when we read this question, try to understand the meaning of this question. Okay, a ray of light falls normally. Okay, here comes the keyword normally. Normal means what, children? Perpendicular. Okay, normally on a rectangular glass slab. That means we have to draw the glass slab first. We will draw a glass slab. Now what happens? A light ray falls normally, perpendicularly to this glass slab. Normal, perpendicularly to this glass slab. Now we have to draw the path of the ray till it emerges out of the slab. We know that if you all know that it is rarer medium, this is glass slab, so denser medium, but the incident ray is normal for the surface, normal to the surface. That means angle of incidence here I is equal to 0. Okay, in this position how it is? If angle of incidence is 0, the light ray passes undeviated. It passes undeviated to the glass slab. Now, here also the angle of incidence is 0. Glass to air, but angle of incidence is 0. So, this comes undeviated. Okay, this is the required diagram. Now, one important thing we have to remember is light ray, how we can show with the help of the direction. So, direction is very important. As you know, it is a 2-mark question. If you draw this complete diagram with direction, we are going to get 2 mark. Okay, and if we did not mark the direction, we will lose 1 mark. That means for a 2-mark question, we are going to get only 1 mark if we did not mark the direction. Okay, only a straight line if we draw, we will get 1 mark. If we mark the directions, then we are going to get 1 more mark. So, we will get 2 mark for this question. Our next question in 2020 paper is, complete the path of the monochromatic light ray AB incident on the surface PQ of the equilateral glass prism PQR till it emerges out of the prism due to refraction. Okay, this is also a 2-mark question. They have given the diagram. This ray is marked as AB. Okay, we have to complete this. Here, the important thing what we have to understand is complete the path of the monochromatic light ray. Monochromatic ray. What is the meaning of that? Monochromatic means only one color. Okay, the other word is polychromatic. We have learned white light is polychromatic in nature. Suppose white light passes through the prism, what happens? It splits into 7 constituent colors. Okay, but here since it is monochromatic, that will not be the single color only. So, splitting will not take place. Okay, so here this is the incident ray. Now, this is air and this is what? It is glass prism. So, air to glass light ray travels. So, what happens? Yeah, it bent towards the normal. So what you will draw is, here this is the actual path. This is the actual path. If it is not having any deviation, that can be the path of the light ray. But here, since it is passing from air to glass, it comes closer to the normal. This is the normal, comes closer to the normal. Okay. So this angle between incident ray and the normal is marked as angle of incidence. This is refraction, R1, angle of refraction. Here again we have to draw the normal. Now the light ray passes from glass to air. That means denser to rarer medium. It moves away from the normal. So it comes like this. This will be the actual path, but it moves away from the normal. So this this can be angle of refraction. And here we will have the emergent angle. That means normal and emergent ray. Angle between emergent ray and the normal is called angle of emergence. Okay. Now we have to extend it backwards. This ray we will extend backwards. Okay. This angle, because this was the actual path of the incident ray. Now it is deviated here, isn't it? So angle between the incident ray and the emergent ray. This can be delta. Angle of deviation, delta. One more important thing. Again, I told you it is 2 mark question. Okay. So for the complete diagram, actually 2 mark we have to get if we have marked the directions properly. If the directions are not marked, we will lose 1 mark. That means for a 2 mark question, we are going to get only 1 mark. I hope it is clear for you all. Okay. Our next question is, where should an object be placed in front of a convex lens in order to get, first one, an enlarged real image and enlarged virtual image. So in this question, they are giving us what? Convex lens. Where should an object be placed in front of a convex lens? Okay. So we have to remember only about convex lens. No? In convex lens, when we will be getting an enlarged real image. Okay. Real images, enlarged images we will get 2 times, but one is highly magnified. Okay. When the object is at focus or f1. Okay. The other case, enlarged and real image we will get when the object is in between f1 and 2f1. So that will be our answer. Not highly magnified. Simply magnified or enlarged means object should be in between f1 and 2f1. For that 1 mark we will get. Okay. One more question is here, that is enlarged virtual image. Okay. You will be remembering only one position. If the object is in between f1 and the lens, or we can say if it is in between f1 and optic center of the lens, in convex mirror we will be getting a virtual image and it is magnified also. So that is the answer here. Object should be kept in between f1 and the lens. Okay, another mark for this. So totally 2 mark. Our next question is, a pond appears to be 2.7 meter deep. If the refractive index of water is 4/3, find the actual depth of the pond. Again 2 mark question. Okay. So here when we read this, we have to understand it is related to real and apparent depth. Okay. What is given here? A pond appears to be 2.7 meter deep. Appears to be. That means that is apparent depth. Okay. So we can write here apparent depth is equal to 2.7 meter. Okay. What else is given? if the refractive index of water is 4 by 3. So refractive index symbol mu is equal to 4 by 3. We have to find the actual depth. Actual depth is, actually we will write it as real depth we have to find out. Okay. We have learned the formula. Refractive index is equal to real depth by apparent depth. Okay. From this we have to find out real depth. What will be real depth? Real depth is equal to cross multiply refractive index into apparent depth. Substitute. Refractive index is given as 4 by 3 into apparent depth is 2.7. So we can get it as 3 and 2.7 we can cancel. 3 ones are 0.9. 4 into 0.9. 4 nines are 36, 1 digit decimal meter. This will be the answer. Why we wrote meter here? Here apparent depth also is in meter. Okay. For this, again, how is the marking comes? It is a 2-mark question. If you have written this step, okay, you will be getting 1 mark for this step. Okay. Next mark, you are going to get, if you wrote this correct answer, 3.6 with unit. 1 more mark you will be getting. Suppose you forgot to write this unit, you are not going to get this mark. Your answer, final mark, you are not going to get. So always you have to remember to write the final result with proper unit. It is very, very important. Okay. So if you have substituted correctly, 1 mark for that. Final answer with correct unit, you are going to get another mark. So totally 2 mark. Our 5th question from this chapter is the wavelengths for the light of red and blue colors are nearly 7.8 into 10 to the power of minus 7 meter and 4.8 into 10 to the power of minus 7 meter respectively. This is the statement given. First question. Which color has the greatest speed in vacuum? Which color has? Second question is which color has a greater speed in glass? Again it is 2-mark question. Each question carries 1 mark. Okay. So here which color has the greater speed in vacuum, and they have given us 2 colors and its wavelength. Okay. But we have to remember one thing, students. What is that? All the colors, all 7 colors will travel with the same speed in air or vacuum. We have learned that. But now seeing 2 colors, we may think, oh, in that then red will be, blue will be. Okay. To confuse you only, they have asked this question. Which color has the greatest speed in vacuum? All the colors are moving with same speed, isn't it? So both the colors or all colors will have same speed in vacuum. Okay. So we can write here as all colors. We can write all colors have the same speed. Same speed were in vacuum. Okay. What is that speed of light in vacuum or air? That is 3 into 10 to the power of 8 meter per second. Same speed. All the colors will have same speed. Okay. So particularly for this, here 2 colors they have asked, both will have same speed. Okay. That is our first part answer. What about second answer? Second question is, so if you write this, all colors have the same speed in vacuum, we are getting 1 mark for that. Okay. Second part, which color has a greater speed in glass? Okay. In glass, out of these 2, which color will have greater speed or more speed? Remember a formula what we have learned? V is equal to F lambda. V is equal to F lambda. Okay. That means velocity is equal to, or speed is equal to frequency into wavelength. So here frequency will not change. for a given color, the same frequency, whether it is in any medium, frequency doesn't change for a given color. Okay. Now lambda we have to see. In this, which is having more wavelength, lambda means wavelength, which is having more wavelength, that will have more speed. Okay. So see here, red is having how much? Red color's wavelength is 7.8 into 10 to the power of minus 7 meter, but blue color's wavelength is 4.8 into 10 to the power of minus 7 meter. So which color has more wavelength? Red. So red will travel fast. Okay. So this answer is red or red color. Okay, you will have next mark. So totally 2 mark. Now we discuss all the 2 mark questions from section 1. We will discuss questions from section 2 in the next class. So please subscribe the channel Pincy's class. Press the bell button to get all the notifications. Thank you.